In this problem, we have the equation minus 2a plus 1/4 b plus negative 3c plus d is equal to 0. I have three vectors. I have a, I have b, I have c. They all three have different magnitudes, and they're all coming in different directions. And what we want to do is we want to find out what vector d is going to be. So move d out of the way so we have some room here. Grab that right there. We'll slide that over here. Okay, first thing we have minus 2a. Now, we know this is vector a, so the minus is going to reverse the direction. So we're going to go ahead and draw another vector. We're going to draw it parallel, but it's going to go back the other direction. And again, I'm going to draw this as close as I can to be in parallel. It's going to go something about like that. Now, this magnitude of this vector is going to be 110 newtons. Okay, don't make it minus 110. The minus only changes the direction. It was going this direction to start out with, so the negative makes it go back the other way. We multiply it by 2, that makes 110 going back. Now the next thing you want to do is to locate the vertical angle, and you got to be careful here. This 35 is coming off of the y-axis, so when you do the vertical angle, it'll be coming back off the y-axis down here, like that. So we're going to grab this angle. We're going to move it back down to here in this location. Now at this point you are done with this vector, so we might as well move it completely out of the way. And we're done with this. Move it out of the way, and actually we'll just delete it, and we'll delete this one. Alright, so what this vector is, this is the minus 2a vector going this way. Alright, now let's do b. b has a magnitude of 30 newtons. So what we're going to do here, we need to reduce this. We're going to take the 30, we're going to multiply that by 1/4. When we multiply 30 by 1/4, we will get 7.5. So this new vector, move this out of the way, is going to have a magnitude of 7.5 newtons. Okay, and you can shorten this if you want. Just so you know, it is a shorter vector, has a magnitude of less than what it had before, which is 30. So now we're done with this. Alright, let's come to the 60. Now the 60 is going to be multiplied by a negative 3. The negative is going to reverse this vector. I'm going to move some of this out of the way because it's going to be a little bit hard to get it all in here. This vector is going to turn around and go back the other direction. Just like this. Now this magnitude here, 3 times 60 gives me 180 newtons. And let's do it a different color actually, since we have blue already. We'll do that in red. That gives me 180 newtons going in this direction. Alright, and now you are done with this vector. And be careful here, this is 40 degrees here. So we're going to take the 40 and we're going to move it down to here. And just go ahead and draw so we know where it's coming from. The 40 is coming off of here and off of here. Now while we're at it, we want to make sure we don't get the 65 and think that has to go with that vector. So we probably should draw some arrows knowing that this vector is coming off, the 65 is coming down to this one and then back to this one. Alright, so now let's go ahead and get rid of the vector we had over here, and it's gone. So this is what minus 2a plus 1/4 b minus 3c would look like. Now we're going to sum these just like we've done before. And what I like to do is we're going to sum the forces, because these are all forces, in the x direction, and we're going to set them equal to 0. Alright. So we'll start with the first one that was 110. So we're going to take 110 and we're going to multiply it by the sine of 35. And again, the reason we're multiplying it by the sine is because the components of this vector, just look at this one here, would come down and go over. So if I'm looking for this vector here, this is the opposite side, so I'm going to use sine here. So this one's going to have a positive x, and you can tell right now it's going to go down when we do the y. Okay, so we'll color code these and we'll get rid of them here in a little bit. But let's just color those orange right now so we know they're components and they're not the magnet, they're not the actual hypotenuse. All right, let's go to the next one. We will do the 7.5. So that's going to be minus 7.5 times the sine of 65. Okay? Again, the reason it's sine, because if you look at the direction that the components of this one would go, the components would go down. That's a little harder. And then they're going to go over like this. The components are going to go. So I'm going to have a negative x, and again, that should be head to head there. Move it into place so you can see it better. We go like that, and we want to shorten this one just slightly. So its components would go something about like that. Alright, so this one's going to have a negative x and a negative y. Alright, now let's go to the next one here. We'll have 180. So that's going to be minus 180 times the cosine of 40 degrees. And again, if you're confused by that, look at this. Its x component's going to go like this. Its y component's going to go down like this. So I'll color these as the components so you can keep this straight. And I'm going to change these like, I don't know, some other color like that. And let's get this one. We'll do this one too. Okay, and now let's come to this one. We'll get its components a different color. Call these components purple. And now let me straighten this one up just a little bit because it's a little crooked. We'll move it out just a little bit. Again, it's not essential you get these perfect, but it gives you an idea what direction they're going to go. So the colors are all the components of the black vectors. Now the last thing I want to recommend is when you do this part, you don't stop right now and say this equals 0. You need to add the x. So we're going to add plus dx. The x component of the d is going to be 0. Alright, I'm going to scroll up just a little bit so I got some more space. Now we're going to sum the forces in the y direction and set it equal to 0. So we'll come back to the 110. We can tell its component is going to go negative. So we put negative 110. This one's going to give me the cosine because it's adjacent to 35. Okay, we got that one. Now we're going to come back to the 7.5. It's coming down. So we're going to go minus 7.5 times the cosine of 65 degrees. That gives us this component here. We come to the purple, and that's going to also be minus 180 times the sine of 40 plus the y component of d must equal to 0. Alright, so now what you want to do is start with either one of these. I'm going to start with the x first. And I'm going to just move everything to the right side except for the dx. And when I do that, will I not get that dx is equal to? So I move this to the other side. This will become negative on the right side. Make that better so you guys can see that. That's the sine of 35 degrees. And that will be plus 7.5 times the sine of 65 plus 180 times the cosine of 40 degrees. That's what our dx is. I'll grab my calculator real quick. And again, make sure that your mode is in degrees, because if it's in radians, you are not going to get the right answer. So minus 110 times the sine of 35 plus 7.5 times the sine of 65 plus 180 times the cosine of 40 gives me a value of 81.59. So we know that dx is equal to 81.59 newtons. Now we'll do dy. We do dy almost identical the way we did dx. dy is going to equal to, we add to move everything to the right side. That's going to give me 110 times the cosine of 35 degrees plus 7.5 times the cosine of 65 degrees plus 180 times the sine of 40 degrees, and that's what dy is going to equal. Again, we'll get our calculator. 110 times the cosine of 35 plus 7.5 times the cosine of 65 plus 180 times the sine of 40 degrees. It gives me a larger value of 208.98 newtons. Okay, so now what we need to do, we need to figure out what the actual magnitude is going to be of d. So to do that, I'm going to scroll down just a little bit more, and you're going to fall back to Pythagorean theorem. So the magnitude of d is going to equal to the square root of each one of these squared, 81.59 squared plus 208.98 squared will give me my magnitude. So we'll get the calculator again. We will square that, plus 81.59, square that, second square root, second answer, and that gives me a value of 224.34 newtons. Okay, so now we have the magnitude. The only thing we have left to do is get our angle. And what I recommend is draw the way the vectors go. Dx is 81.59. So I'm going to draw a vector like this. The y vector is 208.98. I'm going to draw a vector like this. Make that a little bit straighter. Let's grab this and straighten it out. Draw my hypotenuse. So I start with tail, tail here, and I have to end up head, head there. Go ahead and draw where the angle is going to be. The angle is going to be here. Now label these. That gives me 208.98 in the y, 81.59 in the x. So we can say that the tangent of theta is going to equal to opposite 208.98 divided by 81.59. So now we know that theta is equal to the inverse tangent of all this, 208.98 divided by 81.59. Okay, so we'll try that. 208.98 divided by 81.59. We get second tan, second answer, and I get a value of 68.37 degrees. Okay, so the proper way to show this would be like this. The d vector, and we could do this. This is equal to 224.34 newtons, and theta, coming from the x-axis, is equal to 68.37 degrees. And that would be my final answer. Now, if you're out like on a test and you want to check this, go ahead and put the value of the dx and dy back in to this equation here and prove to yourself that it's equal to 0. Take the dy, put back in here, and prove it's equal to 0. If it is, you know you've probably done a correct job. All right, best of luck with these problems.